what I did in class, and I think it's just clear. It's really the same thing, but I just think it comes out clear. We're going to find the derivative of an inverse function. And I don't want to memorize the formula. I got enough stuff to memorize. And you can. If you want to memorize the formula, that's another option. It will appear on the exam. It will appear either in multiple choice or free response, or maybe even both. And I think it was in 2006 or 7, I'm going to find that problem on the free response question where they asked you for this. They have the intermediate value theorem, and then they also have the mean value theorem. And it was a vicious problem. The average score was 1.6 out of 9. Yeah. So I know it's going to be there. And, you know, in the past I always said, oh, it's going to be 1 point. Well, then that year it showed up in free response. So I said, we got to do this. I mean, you were just really kind of stuck on the whole problem. Not necessarily because of this, but it was just a very strange problem. It really isn't that hard. Okay, so I have f of x here, and g of x is the inverse. And where I get confused is with the x's. Well, if f and g are inverses, then what has to be true about f of g of x? They undo each other. So your input was x into g of x. It does something to it. And then you put it back into the one that undoes it. And you come back with what? X. That's what an inverse does. You start with something. You do something to it, like I can knit. And I make a mistake. So then I unravel it all. And I'm back to where I started. Okay? And they're going to ask us to find the derivative of g prime of x. So some of you, and I asked this question myself, because if f and g truly are inverses, then g of f of x. Yeah, sorry, I want the point right there. So I want the derivative of g of x, which is the inverse. And some of you may say, well, g of f of x is also equal to x. Why don't I use that one? So I went and did that one, and I said, it doesn't give me what I want. So that's the reason why you don't do that one. So if you start off in the wrong way, just say, okay, I've got to do the other one. There's two possibilities. So let's find the derivative with respect to x. At least I think I have this in the right order. And so what is the derivative of f of g of x? F prime of g of x times g prime of x, chain rule, equals, yeah, but what is the x dx? 1. So what is g prime of x? And if you look at a graph, if you were to explore this, if we had time to do that, we did it a long time ago, you would look at the picture and you could kind of see that this would be the reciprocal. And it's reciprocal of 1 over f prime of g of x. So what they write in the, when they simplify that all, and this is where I get confused, they say g prime of x is equal to 1 over f prime of y. And then I get all confused. Do I want x? Do I want y? And I have worked problems the way I've done them, the way Mrs. Hurston does them, and I think this is the best way to do it. So we're ready to do a problem. And what we're going to do is start with number 27 on this sheet, the bottom problem. We did 26, correct? Yeah, I think we did. Okay, we did. And then we'll do 28, because 28 is really the same question as 27, and 28 is from 2008, 27 is from 2003. And it's the same question, but it looks more complicated. I don't know that I didn't find that it was more complicated. It looks more complicated. And that was enough to make me say, I think we should start with the easier looking problem. Now, I want to keep this in front of me, but I just derive it. Oh, you memorize it. Honestly, I just derive it. So 27. So f of x is equal to x cubed plus x. And it says g of x is the inverse of x, of f of x, sorry. The very bottom of the sheet, right? And then it says g of 2 is equal to 1. I want to find g prime of 2. When I do the next problem, if you want me to go through the whole process again, I will, because I do it every time. I don't memorize the formula. But I've done the formula, so I might as well use it. So, g prime of 2 is equal to 1 over f prime of g of 2. Right? And this is easy. So this is, because the way I did it, I'd have f prime of y, and you have to realize it's the y value of the inverse function. Well, if I do it this way, it's really clear. It's g of 2 is 1. That is the y value of the g function, or the inverse function. And so what's f prime of 1? Well, I guess I think I have to do some work. I know what f of x is. Can I find f prime of 1? If f of x is equal to x cubed plus x, what's f prime of x? Easy. What is it? 3x squared plus 1. So f prime of x is equal to 4. So then I'm just going to put this in here, and I need 1/4, which the answer is C. No, it isn't that bad. Anybody have the 2008 answer key so we can see, well, I could look it up, see what the percentage was of people who got this right? It's on Blackboard. Didn't I print them up and give them out to you? I did. There's some here and there's some down there. I'm missing a piece of it. Catherine. Oh, this was 2003. Wrong year, wrong year. Is it too complicated to what? If you can do it that way, that's fine. It works. But you have to, for me, the hard part is finding out, and you actually have this on the two. Oh, I have only 2008 in here. On the 2003 exam, it would be on the back page of your answers. I don't know if I have it. Okay, I'll look because I'm just curious to see what that was. But the 2008 is a little more difficult. So we have now forgotten all this. Do we need to do it again, or do you have it? I can do it again. But I looked at when I did 2008-28, there was a lot of stuff there. And so if you look at my work, I've got a lot of stuff written down. So, because it was confusing to me. So what I'm going to do is write up these ordered pairs because I think this helps. They gave you extra information to see if you could sort out which one you have to use. So I think we should start this from the beginning, just like we had not done a problem like this in a while. And it says g of x is equal to the inverse of x. Okay, and I want to find g prime of 3. So you're on the exam, and you see that inverse, and you're going to say, oh, well, if these are inverses, then f of g of x equals x. And you want to think of it this way. Take f of this function, and then f of this function. What does f of f inverse do? Makes it back to x. It undoes it. So now I can see it a little bit better. Now take the derivative, because I've already forgotten what the answer is, even though I've done this problem. I did all these problems. I still forgotten the formula. So, so it's f prime of g of x. And I actually kind of like this because it makes you think of the chain rule. So you're actually doing the calculus times g prime of x equals 1. And then I want to solve for g prime of x, because that's what I'm trying to find. So it's g prime of x equals 1 over f prime of g of x. And so I now want g prime of 3. So g prime of 3 equals 1 over f prime of, well, I want g of 3, right? It's really clear to me. What is g of 3? I'm going to have to slide my board up that you have in front of you. sorry, it's prime, almost a sec. What's g of 3? Now remember, g is the inverse of f. No, this f of 3 is 15. No, g is the inverse. G is the inverse of f. So g of 3 is equal to this. Well, the ordered pair here is 3, 15. This is 6, 3. And these are derivatives. So now you have a 50-50 chance to pick the right ordered pair. So they always are going to do this to you. Now just think for a second. This is the inverse of this. What do you do with inverses? So this is f. So what's g then? You switch the x and the y. So if I do this, this is g of 15 equals 3. That's hence the reason for answer E. You can't find the answer, because if you choose the wrong one, you can't do it. They could have done that or given you a wrong answer. So what's g of 3 now? It's 6. This is what helps me do that. And the other way, if I want to look at that as this is the y-coordinate for g. Well, the y-coordinate for g is the x-coordinate for f. So you can think of it either way, whatever works for you. I double check it with that. And so what's f prime of 6? Negative 2. Now this was a little tougher. So the answer is A. This one we can look up. How many, what's the percentage, do you have that out? What, now this is from 28. How many got this right? Does that make you feel good? Can you do this? Beat out the rest? Thank you for reminding me. They have never done it until 2008. So let's do the problem right now, because we can't get in the lab anyway. And that's problem number 19, 2008. And by the way, pretty sure it was 2008. The actual 2008 exam is scanned with all the solutions written out, so you do have that. But I would like to get you a clean copy. Okay, I don't have one. This is multiple choice. And then tomorrow, I will give you, I should have it back by then, I will give you the scoring guidelines revised, and then I'll show you how to figure out what your score would be and what your grade would be. So if you didn't look at answers and you took it and you graded it, what would you get? So if you've looked at answers and worked things out, I still think you can go back and look at it and say, okay, I wouldn't get this one. You can still count up how many correct. There's no penalty for guessing. So that's kind of nice. Okay, so I want number 19. And this was thrown out because so many people with 5s on the exam did not get this right. Now, I'd love to see what the percentage was. If you 14% of that was not thrown out. This had to be really low. 1% maybe got it right. And I don't know why, because when I think of the problem the way I taught it, we should consider all cases here. Now, maybe we can't find the answer very well. This is asking for horizontal asymptotes. You remember how to find a horizontal asymptote? Do you remember what it is? That's a vertical asymptote. Horizontal asymptote is, I don't care what's happening in here. It doesn't matter. But what is this doing? And the point here is, even though it has an horizontal asymptote to the right, it may not have one at all to the left. It may be the same one, or it might be a different one. Horizontal asymptote is end behavior. So guess what? You have to look at the end behavior, both positive and negative. You have to do 2 limits. But when I taught this, which was a long time ago, pretty sure we did that. But we didn't have any weird functions. We had polynomials, and they do behave the same on both sides. But when you have exponentials and logs, that changes everything up. So I have to take the limit as x goes to infinity, and this is a thinking problem. Personally, I think the negative infinity is a little weak. Well, I don't know. X is going to get really large. So the 5 and the 1 isn't going to matter. So this really looks like, when x gets large, it looks like this limit. As x goes to infinity, you're just going to think 2 to the x over 2 to the x. I could do it algebraically, or I could just think what's true about those two numbers. Oh, sorry. Missed my negative sign easily. Ignoring the negative, what's true about the two numbers? They're the same, aren't they? So what's this limit equal to? -1. Another way to look at it would be to say if you have 2 to the x over 2 to the x, I can pull the negative out front. You can always do that. And that's the same as, you might say, okay, that's 1. Or you can also look at this. It's also the same as this. We need to know that a over b to the x power is a to the x over b to the x. That you can do that. It's a property of exponents. Actually, there's very few properties for exponents, just like logs. That's one of them. Okay, so then that's 1. What's 1 to the x? 1. I don't care what x is. It's 1. Now, if it's a little bit bigger than 1, then, and this is going to infinity, then I might have e. Okay, so the kids got that part. That wasn't the problem. They forgot to do the other side. I think because you do so much with polynomials, you say, well, it's going to be 1 on both sides, same behavior. But it isn't. And then how do you do this? Because you're not allowed a calculator. So what I would say is, why don't you just try it for some numbers? You could do 10. I'd like to make it bigger. Why don't we look at this for x equals to 100? Sorry, not 100. It's negative infinity. So negative 100. Honestly, that's exactly what I do. I put in numbers. If I don't know what's happening, I'll just put some numbers in. So the limit as x approaches negative infinity, I'm actually going to write this number in there. Now let's try 5 plus 2 to the negative 100. And this is 1 minus 2 to the negative 100. Some of you want to neglect the 5 and 1, but you can't do that because it's not parentheses 5 plus 2 to the negative 100. That's a whole different ballgame there. So be careful with that. Let me make it at least a plausible error. So those of you who are not using parentheses, you're having some problems with your parentheses. What? No. Okay, so what does that mean? This is 5 plus 1 over 2 to the 100, right? That's what a negative exponent means. And this is 1 minus 1 over 2 to the 100. Even if you do 10th power, huge. What's happening to this fraction? What's this going to? 0. And this is going to, what's the answer? 5. So you have y equals 5 from this one, and from up here, the horizontal asymptote is y equals negative 1, which is e. Read through all the answers. It's so easy, because I think the negative 1 is the first choice. Is it? Yes. So you see it, oh, it's negative. I think it's more that than actually thinking about the negative infinity. Just say, oh, I see my answer in the first choice. I'm done. Go on. No, read through them all, because they put those distractors in the beginning. So just be careful. I mean, there's a lot of errors on this exam because people just are not careful. Be careful and you'll be okay. Make sure you spend 2 minutes per on each problem. I think you get 3 minutes for each multiple choice calculator-based problem. Pretty sure it's something like that. You could figure out the time, divide by how many problems you have. So you have 55 minutes to do about 28 problems. And then if you don't know what to do, you skip it. And while we're here, maybe we should look at 21. Because 21, only 22% got right. And I know I always focus on the diagram, which is a good thing, but in some senses it can be a bad thing. This is x. This is the position graph, not the velocity graph. And here at 2, we have an inflection point. honestly, it's almost a flag to say, why would they tell me I have an inflection point if I don't need to use it? They gave you an inflection point because you have to use it. So why would they put that in? They don't usually do that. And it says, forget the horizontal tangents, I don't even care about that. For what values of t is the velocity of the particle increasing? That's probably you know you have a horizontal tangent here. So v is equal to 0. V is equal to 0 over there too. Okay, I want the velocity increasing. And the problem is, I think too, is we all teach about the speeding up and slowing down, but you have to look at the question. They're not asking where the particle's speeding up or slowing down. They're asking where the velocity is increasing. Velocity could be negative. I just want it to be increasing. So if f of x is increasing, then how would you know if the function's increasing? What does that tell you? What do you have to look at? F prime. F prime of x is what? Greater than 0. It's positive. I'll show you two ways to think through this problem. So forget that it's velocity. It's a function. How do you know the function's increasing? Well, my function is my velocity. So the derivative of the velocity has to be greater than 0. What is that? That's acceleration, which I still don't see the answer very well, but velocity is dx dt. What is acceleration? It's the second derivative. What does the second derivative tell us about our function? Concavity. So I want it to be concave up. Where is this concave up? That's why they gave me the inflection point. Between what? 0 and 2. I got it wrong too, by the way. Only 22% got this problem right. Because I didn't answer the question. It says, where is the velocity increasing? It is not asking during what time intervals is the particle speeding up or slowing down. It's not asking that question. Let's look at the other way of looking at this. Where is the velocity increasing? What's true about the velocity? Because the velocity is the slope of the tangent line. I wish I had my Inspire because I could drag the point around the curve and you would see what's happening to the slopes. They are increasing, aren't they? This is like -4. That's -3. It's negative, but what's true about the velocity? It's increasing. I mean, it could be speed up slowing down. I didn't ask you about that. See the difference? It says, when is this increasing? It's starting here. It increases. It goes to 0. Now you can really see the velocity is getting bigger and bigger, and now it slows down at my inflection point because the concavity changed. And so the velocity here is now decreasing. And I know my picture's not very good, but this velocity here should be smaller than this velocity there, just because I didn't draw my picture very well. So you could just look at the picture and say, oh, where are the slopes of the tangent lines getting bigger? And that's what it means to be concave up. The first derivative is increasing. Positive velocity just tells me I'm going to the right. It doesn't tell me if I'm increasing my speed or not. When I come up to a stoplight, my velocity is still positive. But am I speeding up or slowing down? I'm slowing down. So the second derivative, another way to explain the concavity, is that v prime is increasing, or the first derivative, dx dt, is increasing. Let's look at the derivative where we're concave down. I'll just draw you a picture. So now we're like this. What's true about your slopes here? This is high. That's like 4. And then it goes to 0. And then it goes negative. So if you're concave down, dx squared, sorry, I wrote that wrong, dt squared is less than 0, it's concave down, the velocity is decreasing. Okay, yeah, that's right. Which is dx dt. So you can answer it either by using the second derivative being positive or the first derivative increasing or the first derivative decreasing. I think it's easier for me. It's quicker and easier for me to use second derivative. But you don't have to. I think it is time for us to go. We'll go for lunch. No.